Welcome back to the Niagara Learning Channel. So we've got a Mac 36NL and I've just put a clean disk on it, and I am running for this video N4.8 version 4.8. The reason I'm running 4.8 even though we're on 4.14 is I want to make a station for my client that would run on 4.8 upwards. So if I designed it on 4.14 then, and he's using still 4.11, then he's going to have some issues. So I always try and run or design a station in 4.8 so it'll work on all the rest. So first of all, we've got to commission this. So the username's not going to be that. It's going to be Tridium and Niagara, all lowercase. It's going to be the password, and we'll wait for that to load up. It's a standard. The standard IP address of the controller is 192.168.1.123. As you can see, I'm using 0. Go through the normal procedure. Let's put in my passphrase. Naturally, you whatever yours is. Put in admin and password. Confirm my password, and then you can put a comment in there if you want. I'll just put Max King and then finish. Now I'll probably be putting you on pause every now and again because sometimes we've got to wait for things to happen, but in this case this is quite fast. Platform administrator, and we're going to commission the station. So you can see it's 4.8.0.110 that I'm using. I'll put you on pause while I get the next screen up. So here's the next screen. I always click the sync with my local system date and time. I'm going to keep the licenses. I don't want to change any licenses, but let's just install the license from the Workbench license service. Oh, by the way, you won't have this Quick Link Solutions license. You won't have that there at the bottom. You would only just have these two. Yes, always WB and UX. Don't bother putting your documents across there. I don't want to transfer a station, but saying that, we could just make one at the moment. So if I go to, I think I'm going to have to cancel out of this. So let me just cancel commissioning. Tools, new station, RAYLEIGH is the station that I'm going to do. It's going to be a controller station, and I'm going to put a password in there for admin. Probably type that in wrong, and again. Finish. So there's my station there, which has got nothing in it at the moment. Alarm service there. So what I will do is I will just make another folder. I'll just put in drivers. New folder. And I'll call it IO, because I'm going to be putting my inputs and outputs in there. And then I would have another folder because I've got schedulers. Man, I could put the schedulers in with the logic. So let's have another folder. Oops. New folder, and we'll call it logic. And in there we will have some schedulers. So let's just put a scheduler in there. Boolean scheduler. Just drop that into there. We're going to have one for AHU1. I'll just put that 24/7 at the moment. Apply Monday to Friday. Copy day. Paste day. Save that. Properties. We'll change the true and the false to occupied. Unoccupied. I'll put a capital U there. Save that. And I know from looking at the points, I've got an AHU2, I've got domestic hot water, what else have I got? I've got a sports hall, I've also got a bowls hall, probably missing some other things. Let's just get the spreadsheet. Let's open that up. Here we go. HWS sports hall, bowl hall, squash courts is another one, and that's about it. So it's using a Mix 38 and a Mac 36. I inputted that in there because I looked at the wire sheet that he sent me. He's done an output, which is fine. We'll still do that for hot water heater 1, 2, 3 and 4. So he's done 4 outputs there, digital outputs. But when I looked at the wire sheet, if I open up the existing panel drawings, and let's just open up, which you can't see at the moment because I'm on my other screen, open with photos and move that across. You're not going to see that much there. Let's zoom that in so it's not that side. I want not that one. This is something done in 2004, 2005 I think. It's using star delta starting. I don't know if you can see that there, star delta starting for the supply fan. Normally we use inverters nowadays, but that's using the old star delta. But anyway, that's not what we're looking at. Let me go back to that one. No, that's them fans. They're the heaters, and that's down to the wire sheet. Let's see if I can find where it was. Here we go. These are the heaters here. Let me just. So we've got heater 1 and heater 2 there. Heater 1 there is using 809 when in auto, so it's one output which is doing heater 1 and is doing heater 2, and then the other output, heater 3, 810, is doing heater 3 and heater 4. And let me just show you on the unit here, the old controller that's been ripped out. HWS 1 and 2 enabled, there's your 809, and HWS 3 and 4 enabled, that's your 810. But what I would do is, this controller's been ripped out, and it's doing like for like with the I/O on the Mac 36. What year was this? This was 2005. So 10 years ago this was installed, and they're replacing it now because they want the graphics on the cloud. They don't want to go into the plant room anymore and look at the what's displayed on the screen on the panel screen. They want to basically look on the cloud, and that's the panel front, which is giving you your water heaters there, individual when you're in hand, but in auto it's not. And the AHU 1 and 2 squash courts, your hot water pump, and that is it. So they've done buttons for the domestic hot water and squash court, but not for the bowl or the sports, but we're still going to put time clocks in for that. And this panel uses an LCD display, which they physically got to go to the panel and see what's going on. Well, the idea of this is they will log in with their mobile or their laptop directly into the cloud server, and they can control all this lot without even going down to the panel, and they can view what the temperatures are without even going down here, and any alarms, of course. So that is it, what we are doing, and I've put them time clocks in there. I'm just going to save this. See this black line out there? I'm just going to right click and save this. So now that's saved, so when I go back into commissioning again, we will deal with that platform administrator, and we will load that one in. Commissioning. Again, it's taking its time. While that's doing that, let's have a look at the notes on here. So we have got it's a Siemens BX BMS with panel screen. Therefore we'll be retrofitting this with a Tridium iSMA Mac and a Mix 38. Right, so go sync, next, licenses, next, next. Now we'll put the station in, and it's down here somewhere. Next. Now it's probably thinking about what modules are we using. Now I know I'm going to be using Modbus, so whatever it's giving me here, I know I need to add Modbus because the Mix 38 is Modbus, and it hasn't picked up a Modbus. So I won't be using BACnet, but I will be using Modbus. You can use a Mix 38 on BACnet if you want to, but I prefer to use Modbus. It uses less resources as well. So that's the one I'm going to be using, and it's just added in them extras for me. I'll be using a graphic package for, oh no, the graphics are going to go on the cloud, so there'll be no graphic package. I want to make sure that kit control is my modules. Yes, I'm going to click that because I want that one to be there, and I want them two there. I'll click that anyway. And kit control, I'll be using kit control for my palette. So I want kit control. I won't be using any graphics packages here. I'm just writing logic. I don't need email because that's coming from the cloud. I won't be using the dashboard service, so I don't need any of that. This is normally Distech stuff. Oh, it says there Distech controls, as you can see. Well, I won't be using any of that. I won't be using BACnet. I certainly won't be using the AX community. Yes, it's okay, but I try and just keep to Niagara items that's within the Niagara palette. I don't want other third party. Won't be using Trend as the driver, but I won't be using Trend on this one. So I can bring in over Trend points if I needed to, but it won't be used on this. I won't be using any FTP stuff. And this is my library, but I won't be using that library here. I'll be using it on the cloud, so I'm not bothered about that, putting that library in there, that graphic library. I won't be using Series Transform, there's no data, over data, and I won't be using Vicon Pro. So that's it. Next. I don't want to reinstall the core software. I've already done a clean disk on there. Dist. That's going to stay the same. That second port, I always use that. That's going to stay the same. There's no changes there. And now it's going to do that for me. And then it's going to reboot, and then we can go in. There's no point in you watching this, so let's put you on pause. Just to show you that this has gone through okay. So now closing and the system's rebooting. So once it's rebooted, I will show you from there where we go. I've just clicked on Application Director here, and it's running through Fox port 4911. Starting it up. Don't seem to be any issues there. So it's running now. See, it's saying running. So let's see whether it is running. Open up station 4911, which is what we're using. Secure TLS connection. Right, it's opened it up here on this other screen. I'm just going to accept that. And username and password. And that's it. We are in the station. So we've got a lot of things to do here. As our Niagara network, which we need to put in the server that we're talking to, and it's got the 2 folders that I did, and that's about it. So under drivers, in fact, I'm going to move them 2 folders, cut, and put it under config, paste, so I get it out of the drivers. Click on drivers, new driver. So the iSMA IO network is what we're using with the Mac 36. I'm going to just leave it exactly as it is. So that's another driver. And we want the Modbus, and Modbus async network. And I'll just leave that as it is. Could not invoke, and we couldn't invoke because we're missing a module. Okay, so go back to Software Manager. It should take sometimes a while to load up, but it's done it okay there. So why are we missing Modbus module? Modbus, here we go, this, install, should click the other one, which it has, okay, commit. So I missed that when I was picking them out. go back to drivers, new, Modbus. Who are you? There we go, Modbus. Okay, okay. Now that's normal because I haven't given it a port. So views, AX property sheet, and that's the port I'm going to be using, COM1, and I presume it's going to be the default setting on here, and they stay exactly the same, non-parity 8 and 1. This is for a mix 38. Now I don't have a mix 38 attached to this, but I know it uses default 115200 board. So what I can do is go to my iSMA modules while I'm here, and I can go to the Modbus async there, and I've got my mix 38 there, and I'm just going to bring this iSMA B mix 38 number 1 and drop it in there. It will go yellow or orange because it's not connected. We don't have a mix module connected, so that was expected. Let's just show you that in wire sheet mode. So I can use one proxy point for all these if I wanted to, but the digitals I can use it for, but the universals I'm going to have to put universals across, and these are my DOs and my analog outputs I put across there. So while we're in here, let's, in fact, yeah, 10K3A1, oh that's on the Mac. So let me bring you across this so you can see what I'm looking at. So then 10K3A1's on the Mac. So that's all Mac. So the mix 38, we are using universal input 1 and 2 for the status. So they're going to be digital. And we've got no analog outputs at all here, so we don't need that, and we've just got digital outputs, so that's not bad. We've just got 2 analogs there, but the fault statuses so they're on or off. So that's good for me because I can use the universals 1 and 2 which we are using. They can stay within there. In fact, I'll leave it all as it is. So I'm using just one proxy point for all them and one proxy point for all them outputs, because we're not using them at all. So that's good. But what would happen with the analog output if we was using that and we put that to true? So when we actually put an input in there to true, it will just give 10 volts on the analog outputs if we use it, if we keep within this. So we'll leave that as it is. Let's go back into the iSMA network. Now again, bring that across there. I'm going to be using the, so we've got a spare there. Then they're all temperature sensors, and we've got 2 analog outputs, so it's straightforward. There's no issue there with temperature sensors being 0 to 10 volts or anything like that. So new iSMA device. Okay, okay. Click into there. New digital input. Well, we've got 4 digital inputs, even though one's a spare. And I don't like the way it does this. I like that to be digital input 4. It's just me, that's all. I don't like it without a number in front of it. 2, and that's going to be digital input 1. Okay, so they're my 4 inputs, and then we've got universals. So new universal inputs, and I think we've got 16. So I'm looking at my controller here. We have got 16, I believe. And again, I don't like this. I just like to keep it as the number for the input. 14, 13, 12, 11. So straight away I know that's going to be input 11, and this one's going to be input 10 and not input 9 as it's saying there. 9, 8, 7, 6, 5, of course 4, 3, and then 2, and then that one is input 1. And all these are going to be temperature sensors, so I'll just highlight them all. I press the control key on the bottom one there to highlight it all, and I'm going to put it to 10K3A1. So they're all 10K3A1 sensors. Go OK to that. So that puts all them in there. And then we've got our analog outputs, which will be 6 of them. So new. They're not being used, by the way, but we'll still put them in. 6 of them. And of course, my normal changing of the numbers. 4, 3, 2, and 1. Again, they're not being used. And then we've got our digital outputs, which are 8 of them. New digital outputs, 8 of them. Some of them, the last one is spare, but let's do this. 8, 7, 6, 5, 4, 3. Normally I cut all this lot out. I normally do it all before, but I just thought you can see exactly what I'm doing there. I'm not renaming any of these because I'm not going to use, I'm going to just link to them only. Let me show you what I mean. So if I go to my IO folder here, which should be nothing in there at the moment, again I'm referring to this. I'm on the Mac 36 and the sheet there. So I'm referring to these points here that I'll be putting in there. So first one is a numeric, is a Boolean writable, and that is fire alarm status. Now I'm not using any spaces and I'm not using any underscores. And I'm going to take out that int16. As you know, on all my videos it's some sort of OCD thing. And action set to false at the moment. And that's that one done, apart from putting the alarm on it and changing the font. But what I'm going to do, in fact I'll put the alarm on it now. So it's there, fire alarm status. Let's go to alarm mode, alarms palette, and extensions. And we're going to do a Boolean change of state. Drop that into there. I don't rename it or anything like that. I leave it as it is. And we're using default alarm class because this is all going straight back to the cloud server. So the alarm value is actually going to be false, because a fire alarm normally is safety, circuit, and made is going to be, i.e. the contact is made, it's going to be healthy. And yet if the contact is broken, it's going to be false. So that way, if anyone decides to cut through the cable, it's going to just shut everything down. Where if it was the other way around and someone, i.e. true to say fire alarm, if someone cut through the cable, you wouldn't know there's a fire, because it's still going to be in the false state. So we call that fail safe. So off normal text, fire, exclamation mark, healthy, and fault, exclamation mark. And that is basically it. I'm not going to bother with that. It's only that I'm interested in, the alarm value there, and go save. Display name, I just wanted to say whatever the point is called, which is fire alarm status, and save that. I don't want any delays, I want it to go off straight away. And then I'm going to just name these as true is healthy and false is fire, exclamation mark. Save that. So when we look at that now, we can see it's in fire because we've put it to false. So that's that one done. The next one, I'm just going to duplicate that, and the next one is safety, circuit, status. Again, that would probably be fail safe. So we can leave the alarm in there, but we've got to change the text on the alarm. So that's healthy, and that is safety. It could be emergency stop. In fact, looking at it, looking at the drawings, it probably is an emergency stop. But safety covers everything for me, and we need to change that. Save that one. The next one is gas valve open status. So duplicate that. Gas valve open status. And again, it's going to be the same. So we'll put the alarm is gas valve open, exclamation mark, and here we'll just put gas open, exclamation mark. Oh no, gas valve or gas issue. It keeps it short instead of putting the valve in there. And healthy. Save. Gas issue. The next one is a spare. Duplicate. And that is a spare. So spare. In fact, what I'll do here is I'll put the DI04 in front of that. Now that spare, I'm going to take out the alarm. We don't need that. And actions, we want to change that to back to true and false. And this one, I'm going to put DI03 in front of it. This one, DI02, and this one, DI01. and I have used an underscore. I don't like using spaces. I prefer to put an underscore in there. We don't need to really put histories on these because they're already going to have the history in the alarms, but I am going to still put a history in there so I can trend if I needed to, if we've got issues. So it's a Boolean, and I want a Boolean COV, which means change of value. And in the history, I'm going to leave it really the same, the parent name. So it's going to be DIO1 fire alarm status as a parent name. I'm going to enable them all later. I'm not going to do them individually. And I've got a record count of 500. Hopefully you won't have many of them anyway. But all the histories will be taken to the cloud server later on, which will store it indefinitely. There won't be a history capacity on that. And I'm not going to put an history on a spare. There's no point in putting a history on a spare. Right, so that's them done. Now we've got some temperature sensors. So they've got to be numeric writable. And I'm just going to do UI 01 underscore. This is outside air temp. We normally just use an abbreviation of OAT. And we know it's going to be in Celsius because we're in the UK. So we'll go down to our temperature and we'll select Celsius. And we're leaving everything else as it is. So I'll save that. Right. So we put it to Celsius and action set. We'll just set that at 0 at the moment. There's our Celsius there. I will take out in 16 like I always do. And in here now I am going to put a history, and that's going to be a numeric change of value. I'm going to drop that into there. Again, I'm not going to need to change anything in here because it's just going to say the outside air is 500. I could change the tolerance. We don't need it to be exactly precise, so we can say that every 1 degree we write the history there on that one. The next one is AHU supply temperature, AHU1, so duplicate, UI2, AHU1 sub. In fact, it doesn't really make any difference. I've still got to go back in and change it. So supply AHU1 supply, duplicate AHU1 extract, so that's 3, extract, and then we've got AHU2 supply, duplicate AHU2 supply, and duplicated that again, AHU, so we're on 5 now, extract. Now what do we have? HWS flow temperature. So that's UI6, HWS flow. I've put a gap in there because I didn't want with the HWS S being a capital, I thought it wise to put a gap and put flow there. and then all the rest are spare. I'll do one spare and then I'll put you on hold. So duplicate UI7 spare, and because that's a spare and I'm going to be duplicating it, we're going to take out that numeric history. Right, let me put you on pause and do the others. So I've just moved them naturally across here so you can see there's 16 there. So we've got quite a few spares that we've got on the Mac 36. Right, what I want to do with them though is I want to find out if this is faulty, this sensor or any of these sensors. I want to know about it. I want an alarm. So we'll go back to our alarm, and this out of range sensor in the extensions, we'll drop that into the outside air temperature sensor. Now I know we can get down to -40 in this country, we can get to 35, 36, 37. So I naturally don't want false alarms. So I would say that we would never get at this moment in time to 150 degrees outside. And I would also say that we would never get to -50 outside. And we'll just put a 1 degree deadband. That's 0.5 either side. And I would say that that is going to be a faulty sensor. If it gets to that. And click low, click high. And we'll put the faulty sensor there. Faulty sensor. And we'll also put fault sensor up there. And we can have that for all of the others, because none of them will reach that. So I'm going to just paste that into there. You can see it in there now. You can see this one hasn't got it in there. Paste it into there. Paste it into there. Paste it into there. Paste it into there. And that's it. We don't need to paste it into the spares. So we've got a sensor fault there. I mean, we also know that AHU1, if it's supplying air above, well, depending how old it is, but if it's supplying air above 70, well, normally an AHU supplies at around about 21, 22 degrees. If it's a pool area, 30, 35. So if it starts supplying at 40, we've got an issue there. We've got the heater battery stuck on or something like that. But I'm not going to put an alarm on that yet. And the extract, well, you would never pull back 40 degree air back from the room. Otherwise, it's damn hot in there. So really, we could actually put other alarms in there. In fact, let's stick one in there. So we can go for out of range again, and that's the one that we've got to go for. An AHU supply out of range. So yeah, let's put the 1 at the end, which is fine. In fact, let's delete that and let's just duplicate that, because I've already put text in there. So again, it's put the 1 at the end. And we're going to take the low off. Mind you, if the low is at 10 degrees, that's going to be an issue. And if the high is at 50 degrees on an AHU, I would say that's going to be an issue. Check heat exchanger stroke valve stroke sensor. we're not going to have that for the low limit because there's going to be no, so we can still paste that in there and check sensor, and we can paste that in there, check heat exchanger valve. I want somewhat generic to it all. Let's just check temperature sensor, and we'll use that for that down there as well. Save. Copy. We'll do it for the extract. Paste. Paste. For this one, the domestic water flow, that's naturally can get to 65-70. So we don't want 80 degrees domestic hot water, and if the pipes are really cold and it's not working, we don't want 10 degrees. So we'll put check domestic hot water, domestic hot water valve and sensor there. Check domestic hot water. It's not going to be, if it's low, it's not going to be that, but domestic hot water sensor. And we'll take that and we'll put that into there as well. It's overkill. It really is overkill, but it's, you never know. You never know. Right, we're still back to IOs, aren't we? So there's our inputs, and we've still got some outputs. We've got two analog outputs here for the AHU1 face bypass damper. So bypass damper, so it's got a bypass damper. So new numeric rate writable AO1 AHU. In fact, let's do it the other way this time. Bypass damper AHU1. Really? DAMPER AHU1. Pin slots. Take out the in16. Actions set to 0. Now I'm going to be using 0 to 100% here. So I am going to change this here to percent. Let's show you how we do it here. So we leave it the miscellaneous, and I just click on percent there, and I'm going to take out the decimal place at the end. So that's AHU1. I'm going to put a history on that. So history and numeric change of value. And we'll just put a 1 there, and that will be fine. And 500 again. Save. I'm going to duplicate that. It's put the 2 at the end for me, but I've still got to go in and edit it to put that to 2. And then I'm going to duplicate that, and we've got 3, which is spare. And before I duplicate it again, take out that because I don't want the histories on spare. Duplicate 4, spare, duplicate 5, spare, and finally duplicate 6. spare. Now they won't be in order on this page now on the wire sheet, so let's just put them in order. 3, 4, 5, 6. So they're my analog outputs, and which eventually we'll be putting them to the points, which is in this folder here. So now we've got digital outputs, and we've got 1 spare out of the 8. So new Boolean writable. So DO underscore 1. In fact, let's take out the underscore there. Digital output 1, and that is HWS. I'm going to use an underscore. Return. I'm not going to use an underscore now. Pump. Enable. Take out my 16. You don't have to do this, it's just me, it's just my OCD. You don't have to do that. And then I'm going to change the font to enable, the text to enable, and disable. And let's just actions, set it to disable. And I want to put in there a history Boolean change of value, drop that into there. Parent name's fine, history's fine at 500, I'm happy with that. So that means I can then duplicate that one, but I'm going to duplicate it this time on the wire sheet rather than in this side navigation bar. Duplicate, and that's this DO2, which is HWS heater number 1 enabled. Heater, I'm just going to do enable, and then NO1. HWS heater enable number 1 for digital output 2. Duplicate that, and that's going to be 3. Or I'll tell you what we could do, which may be handy for future. Let's delete that. Show you another little thing we can do here. In this digital output here, if we go into our kit control and we go to our control palette and our extensions, we can put a discrete totalizer on it. That would tell us how many starts and stops and tell us how long it's been running for. So there's our discrete totalizer. See where you got the elapsed time, so we know how long it's been enabled for, and we've got the change of state count there. Now what I'll do with that is I will go into this here, right click, composite, and I'll put them out so we can actually see. Not bothered about change of state time, but count definitely want, and elapsed time. And then I'll put these resets so I can easily reset it. So yes, it makes it a bit bigger, but it gives you a lot more information controls wise of how many times it stopped and started and how long it's actually been running for. So I'm going to duplicate that now, Now I've got that in there, and then now put the other one in. So HWS heater enable number 1. Duplicate that again. It's already changed the 1 to a 2, so I'm not worried about that. 3. Duplicate again. 4. And duplicate again. 5. So they're my 4 heaters. And then we've got sports hall heating and bowl hall heating. So duplicate. 6. Underscore. And sports hall heating. I could put enable there if I wanted to, but I'm going to leave it as it is there. And duplicate again. 7. BOWL hall heating. And then we have a spare. I think I am just going to do a new one straight away, because there's nothing going to be on that. Boon and writable. DO8 spare. It's probably just easier to do the spare than it would be to duplicate. Actions set to false and take out in 16. And that is it for the I/O for the Mac. So let's join the dots now. So that's an input, link mark. And let's go to our iSMA device, Mac 36. Link 2, out from that input, into there. Done. Link mark. Link 2, out, into there. Link mark. Link 2, out, into there. Link mark. Link 2, out, into there. Now I've got to do all these. Link mark. Link 2, out, into there. Link mark. Link 2, out, into there. See how the alarms are showing because we're minus 3276.8 because there's no temperature sensors attached. Link mark. Link 2. And see, I'm matching the number for number, where if that had no number, I could easily get confused. I could link that one, which would have normally a number 1, to actually 1 there. So it's easier to link mark, number them at the beginning properly and not use a default numbering strategy. Link 2. Now you could, if you wanted to, rename all these, so that would be outside air and you didn't have to go with this I/O sheet. What I find, it's better to do it this way. I never look at the I/O, I'm looking here, and if I'm overriding here. And you can't override digital inputs. You've got no actions there, so you can't test it, you can't override it. And the temperature sensor there, you can't override it, where this input here I can override, so I can put it to whatever temperature I want. So I find it the best way even though I'm duplicating it as such, I've got all my alarms in here, my numerics. I don't put anything in any of these whatsoever. They just come as they are. And I think that's the best way to go. Unless you think of anything different, and by all means comment in the bottom. But I can't think of a better way to do this, because I have full control over the override of the... Now that didn't go into alarm because we didn't have a sensor attached, so that's good. We expected that. Link mark, link 2, out into there. Link mark, link 2. By all means fast forward the video a little bit here because I've got a few to do. And I'm sure you're getting sick of this and my voice talking while I'm linking these up. I don't know if I've got a look of concentration on my face, but I am trying to concentrate and talk at the same time. I'm probably coming out with a load of rubbish, but it's better than a silent screen, I presume, and no one talking. Nearly there, he says. A lot of preparation, but I like this preparation bit, and it gives me a feel of what inputs and outputs I have got to play with. So that's that one done. So now let's do the outputs. Link mark. Now from here I'm going the opposite way. I'm linking from that block into in 10 of the unit. Link mark, link from that into in 10. Link mark, link from. Yes, you're getting sick of my voice now, aren't you? Link mark, just put your sound down a little bit. Link from. Link mark, link from. So I was just looking at the camera to see if I've got a concentration face, but link mark, link from. Right, we've got to do some further changes here because this is expecting a 0 to 10 volt and yet we're doing 0 to 100, so we've got to move a decimal place on there in a bit. Link mark, link from, out into there. Link mark, link from, out into there. Link mark, from, out into there. Link mark, link from, out into there. Link mark, link from. Yes, I'm getting bored with this as well. I haven't done any logic writing yet. Link from, out into there, but it's preparation. Link mark, link from, out into there. Right, we've got no changes there, but we do have to change this. So that's going into there. Analog output. Open up proxy, and we've got a linear conversion of 1, and I am using not 1 to 10, so if that was 10 volts, that would give me 10 volts. I am using 0 to 100. So that should be my scale. Now, I'm going to test that and see. But that should be, so when I put that at 100%, I should get 10 volts. When I put it at 10%, I should get 1 volt. And I've got to do that for all the others. So let me put you on pause. Well, I'm going to just set this. In fact, I won't set it there. I'll set it here. Actions, set, and I'm going to set something like 85%. So because I've got nothing on the in 10, it's actually let me do that. If I had a 0 on the in 10, I'd have to do emergency override, which would be actions, emergency override. But because I've got nothing coming in yet, because I'm not tied in the logic to any of this, so I should have 8.5 volts there. So I can see the output is actually on, but I don't know what voltage it is there, whether it is 8.5 volts or not. So I'm just going to get my digital meter and test that. So let me just put you on pause. Right, I've got my digital meter, dropping it all over the place, and I've got my red lead on A1 and my black lead on ground. Excuse the dirtiness of the meter, but you can see it's showing 8.3 there. Let me just put that down and let me go up and change that actions, set that to, I don't know, 62, go OK, and that's now showing 6. I mean, it's changing. So we're on DC, as you can see there, and we're at 6 there. We just do one more test. Actions, set that at just 10%. So I should see around about 1 volt. And you got your 1 volt there. Take my meters off, and that's it. So we're good to go with that change. So what we've got to do now is do the others. So 1, 0, save, go back, and this one, 1, 0, save. My mouse is playing up. Go back. Okay, probably I didn't save it. Oh, yeah. Definitely not. That's it. Save. I'll just do the others, put you on pause, and I'll also clean my mouse as well. Okay, that is done. So now when we give it 100%, we know it's 10 volts. So that's good. Let's put that back to just to 0 for now. Right, so now we've done that, we need to do the mix. So I can actually close that one down, and we need to concentrate now on these points. This actually shouldn't be that hard. move these with a gap of 2 squares between them, and let's do new text block Mac36 NL. I'm going to highlight that because that's just that, it's not showing the text there. Now I can put the text in. Max36 NL, we'll give it a border, we'll make it bold, and we'll give it 20, and we'll put a background in of a yellow, and we'll put that up there. I think we'll put a bit more text in there. Mac36 inputs and outputs. And then we duplicate that, and this is going to be the Mix 38 module that you'd be using. And we'll change that to Mix 38 inputs and outputs. So we have one page only, but we're showing all our inputs and outputs on that page. Now we've got to start with the Mix 38. So I've gone to the spreadsheet, gone to the Mix 38 tab, and now we're doing these. Okay, so with a numeric, a 0 will be off, and a 1 or anything above a 0 basically will be on. So even though these are going to be numeric points, universal inputs, or because the Mix 38 only has 12 digital inputs, doesn't have any more, so then we've got to start on using one of the 8 universal inputs on a Mix 38. Hence that's why he's done that on the spreadsheet. And then of course we've just got all them outputs, and we're not using any analog, but I'll probably still put them on our I/O sheet as spares. So we have got them all available if we need to, or when he's on site he needs to change something. So the first one's going to be definitely a digital input, because we've got 12 of them. So we can do DI. Because we've got 12, I am going to put this as a 0, 1 this time, not just a DI1. And you're saying that I did 0, 1, 2, 3 and 4 there, and I did zeros there, so that's fine. And this one is AHU1 holes frost status. AHU1 holes frost status. I'm just going to put it down there so I can just get the sizing right to what I've been using. Now I can put it back up there. Yes, I'm going to take out the in16. And yes, I'm going to set that to false. So I think, and normally it's the case, that false is going to be healthy. And I think true is going to be frost. So if we get that back input that we've got frost, then we want to put an alarm on that. So let's get back down to our unit there, digital input 1, and let's get to alarms, and Boolean change of state alarm we'll put into there. and we'll change it to say frost, and that is healthy. Healthy, that is fault. And frost is the alarm value. Save that. And I'm also going to put a history on that point. Histories, where are you? Histories, you're there. And Boolean change of value. Oops, whatever. Idiot. Can't go to there. And we'll keep the parent name as it is, and we'll keep the 500 records as it is. So that's fine for that one. AHU, the next one is AHU2 DX unit fault status. So duplicate that. In fact, let's just duplicate this way. Saves me from reordering it. So digital input 2 is DX AHU2 DX unit. DX unit fault. Again, I think it's going to be the same. We've got to put that as fault now. And we'll just go into the alarms, yes. And we'll put that as fault. And we'll leave everything else as it is. Save. The history is still going to change, is still going to be the same. We don't need to change that. So the next one is AHU1 hose supply flow fan status. So duplicate 3. Sorry. AHU1 hose supply fan flow. That's okay. DIO3, AHU1, AHU1. But this time we've got to change some text here. So no flow, flow. And we don't want to attach an alarm to this. Naturally, we don't want it to go off in an alarm when it's got a flow. Go back, save that. Yes, thank you for reminding me. And I'm going to put these just up there because I've got quite a few here, haven't I? AHU1 hose extract fan full status. So I can just duplicate that one. I can do 3. And I can get extract and take out the 1 at the end. So that one was an easy one. The next one is AHU2 supply fan flow status. Okay, duplicate 5 AHU2 supply fan AHU2 supply fan flow status. Now the next one is AHU2 extract fan number 1. So that's telling me straight away when I do my graphics that I've actually got 2 extract fans, because I've got an extract fan 1 and an extract fan 2 on AHU2. Extract fan 1 flow. In fact, I think I might put an underscore there as well. That's 6. Duplicate. 7. Extract fan 2. So 2 extract fans. 1 supply fan, 2 extract fans. AHU2 frost status, where we can actually just pinch this one here. Duplicate. DIO8. AHU2 frost status. So we also know that AHU1 is for the hull. Bear in mind, I don't know this site. I'm only going with text here, but I know that AHU1 is actually for the hull. AHU2, I don't know what it's for because it's not told me here. Next one, again, and we want an alarm on it because it's CW booster set fault. So 909. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, just checking that we haven't missed a number. CW booster set fault. Now again, it would normally be fault will be a true on that, but it could be the opposite way around. But at the moment, I am going to put that as a true and change the text to say fault and leave everything else as it is. That's that one. HWS return pump flow status, so we can actually use one of them. Duplicate, and this is 10, and it is, I'll take it all out. HWS, because I've got a capital, I'm going to use a space there. Return pump flow. That's my for checking that. It is running. Hot water number heater number 1 fault status. So we can use that, duplicate it, and that's going to be 11. And hot water heater, hot water heater fault. So I'm going to put fault this time, and then NL1 number 1, hot water heater fault number 1. Just double check that, yeah, we've got the fault for the alarm there, and we've got fault there. But what I can do there is heater fault. The title will tell them that it's number 1, and duplicate that, change that to a 12, and we've got no other changes to make because we didn't mention number 1 in the alarm because it's in the title. Duplicate 13. We've only got 12. Yeah, that's fine. 13, because that still needs to be digital for me. And duplicate, it's actually not going to be, it's actually universal input 1. So this is going to be UI 2, UI 02. Rename UI 01, universal input 1. Let's put them here. and then that's your 3 and your 4, and then all the rest are spare. So I'll just do 1 spare here, and then I put you on pause and do the remainder. There's no point in you watching me do all these. And I'm going to change the text to false, true, false. Okay, save, and I'm going to take out the history and the alarm. We don't need them, and then I can just duplicate them. Let me put you on pause. Right, so that's done. If you notice, you see where it's put a 1 there and a 1 there. That's because I've already got a UI07 spare there on the Mac 36. So hence, it's put a 1 there. Now, if I want to change that, I can actually take out that S, put a small s, and take off the 1, and it will accept it. Put a small s, take out the 1, and it accepts that because it's not exactly the same point as that one. So the next things we've got to do is the digital outputs. AHU1 hose supply fan enable. Right, so I was looking at something that I could actually copy, and I might as well just take that one and duplicate it, because it's got the what's the word, totalizer in there, so for points and the time. So we'll use that one, and it's AHU1 hose supply fan enable. Again, it's just going to be disable and enable, and we've got a Boolean change of value as well in there, which is fine. Yeah, discrete totalizer. I was working for the when I couldn't remember what it was called. Duplicate. It's still AHU1, but this time it is hose extract. Fan enable. And then the next one is AHU1 hose gas heater enable. AHU1 hose gas heater enable. Digital output 3. Digital output 4 is supply AHU2 supply fan enable. Didn't tell me what AHU2 was feeding, but so the next one is 4 underscore AHU2, and it's supply fan enable. Supply fan enable. One, two, three, 4. So 5 gas AHU2 gas heater enable. Duplicate. 5 AHU2 gas heater enable. 6 AHU2 extract fan number 1 enable. Extract fan NO1 Let's have a capital N there. Enable. And I still got DO2 there. Rename DO6. And 7 is the same, but it's extract fan 2. Take out the 1 at the end, it will be there because it thinks I'm duplicating it, which I am technically duplicating it but renaming it. Right, 8 is AHU2 DX unit stage 1 enable and AHU2 DX unit stage 2 enable. Now I'm thinking, what are these? So this DX unit is naturally going to be a heating coil or a cooling coil, because DX can be cooling as well, but I presume it's going to be heating because it's doing a hull, not a hull, but I presume it's going to be doing a pool. So I think that's been heating. So I'm just thinking for future when I'm doing my graphics, that's all. Duplicate DO8 and my control logic, of course, and DX unit stage 1. So 9 is stage 2. So 9 stage 2. Take out the 1 at the end. Ten is squash court 1 reheater enable. 10. Squash court reheater. Squash court, we'll do a number 1 reheater enable. That's quite a long text, isn't it? I presume it would fit on the history, but rename reheat. Squash court number 1 reheat. I don't even have to put enable, but I'll leave it as it is. Duplicate 11 2. So there's 2 reheats in the squash court. Maybe AHU2 does the squash court, you know, and everything else, and that's why it's got a reheat. And the last one is spare, which is digital output 12. Duplicate digital output 12 is spare. I'm going to leave disable and enable in there because we can, and normally outputs are enabled, disabled, but I'll leave that in there. Just take out the history. So the only ones that's got alarms are them at the beginning here, and that has got an alarm attached to it. I'm just checking that I don't want an alarm on pump flow. I do want an alarm on that. I want an alarm on frost. I want an alarm on the DX unit fault, and I want an alarm on that frost. So that is all the I/O that we've done, but we've now got to link this. Now this should be the easy part, especially with the mix. So if I go into my mix, views, wire sheet, and this digital inputs here, if I just link mark that, which I could have just done from here as well, link mark, same thing. Go back, and to my mix 38, link from DI1 into there, link from DI2 into there, link from DI3 into my in10, link from DI4 into my in10. You get the picture. Quite simple really. DI6 into my in10. Link from DI7 into my in10. Again, fast forward this if you get you falling asleep. DI8, and because I was talking, I didn't know which one I was on there. Link from DI9 into in10. Link from DI10 to in10. Link from DI11 into in10. Link from DI12 into in10. Now this one, link from UI1 into in10. Link from UI2 into in10. Link from UI3 into in10. Link from UI4 into in10. I didn't want to do a link to. Link from UI5 into in10. Link from UI6 into in10. Link from UI7 and link from UI8. So that means I have got these 12 and these 8 just using one proxy point, Niagara proxy point. So I've got all these inputs just using one proxy point. So that saves quite a bit on licensing. Now let's do the outputs. Highlight that mix 38 digital outputs. Link mark. And then this one, link from, no, link to out. So my DO1 hall supply fan enable into DO1 of the mix 38. Link to DO2 of the mix there. See how the DO1's now greyed out because I've already got a link into there. Link to out 3. Link to out 4. Link to out 5. Link to out 6. Link to out 7. Link to out 8. Link to out 9. Link to out 10. Link to out 11. Link to out 12. So again, I have got 12 digital outputs, but only using one proxy point, which is nice. And I haven't even looked at AO 1, 2, 3, 4, 5 and 6. I didn't put them on there. So should we do that? I think we should. New. numeric writable. AO is only, so I'm not going to put a 0. Spare let's get the size. Keep it nice, neat and tidy. That's what I do like with my logic. I like to try and keep it tidy. Actions set to 0. I'm not putting nothing on it because it's pointless. But what I'll tell you what I will do. I'll do the 0%, the percent there. See the units percent. Let's do that one, because I would always work in 0 to 100. Duplicate 2 spare. Duplicate 3 spare. Duplicate. Why is 3 spare? Oh, 3 spares got a 1 there because of that. Rename small s. Duplicate 4. Duplicate 5. Now I don't know if you're thinking, why don't it put a numeric totalizer on there? Well, the spare for a start, and I never normally do on analogs, but just to show you that it can be done, if we go to this spares here that we've got here and go back to kit control, and you got your numeric one there, and you can actually put on there if you wanted to. Totalize an interval minute or hourly. That's what you've got basically with that one, numeric totalizer. But I'm going to take that back off because I don't want that. Right, now I've got to put these in there, which again will be simple because all we're doing is link mark that. I'm not putting separate AOs in there because they're spares. Link to out. Aha, wrong way. No, it's not. It's the right way. Yeah. Link to. Link to. Link to. Link to. We'll soon be able to start on the logic now. Link to. Right, I don't need that anymore. I'm just working in this IO folder, and then I've got my logic, which has just got some time clocks in there at the moment. Right, so let's start. Safeties first. Safeties. Make a new folder. Call it safety. Go into my folder. We've got fire alarm, safety circuit. Now I could just copy and paste them and take out the, but it's short as it's long, so fire alarm. Pin slots, take out my in16. Action set to false. Duplicate safety circuit. That's going to be the emergency stops normally. And gas valve. Well, we don't want the AHUs to stop, especially the one that's got the DX, if the gas valve is being operated. But naturally, do we need, so DX units, AHU2's got DX units. Reheater enables. Let's put it in anyway. Duplicate, because it is a safety. Gas valve. But that's going to be either open or closed. So let's just change that to open or closed. Open, closed. And then I am just going to put in an output, which we call that safety, healthy. So that's my output on the right hand side. Action, set that to false. And safety, let's change that to gas. No, safety healthy. I'm going to do another one. Gas safety healthy. So we've got two different outputs, three inputs. Right, let's go into this logic and this safety. I'm going to right click that. I'm going to composite. And then I'm going to go into the fire alarm and intent, because that's an input into there for me. Into this folder. They're inputs. Now these two are outputs for me. And I have to also name them as well. So that's them nibs put on there, which is just showing it to the other side of the folder, and the same here. Now I do know that we're going to not have anything in there. So I've gone in the AX slot sheet. That's fire alarm. I can use spaces here. There's no problem with that. That is safety. And I put EMG stops, because I saw that on the drawing. And that is gas valve. And that is safety's healthy. And that is gas safety healthy. Right, so if I show you this, this is my outputs there. Let's just size this up to the same as them there. In fact, let's put that down there, out of the way. So link mark, and from my IO folder we have got the fire alarm, so link to, out, fire alarm. Link to, out, safety emergency stops. Link to, out, gas valve. All in alarm at the moment. So that needs to be a true in order to be healthy. So let's put it to true, which we can because we've done our own IO. So let's put that to healthy, and let's put that to healthy. I've got emergency override. Sorry about that, because I've got my point going into it now. Actions, emergency active. Gas valve, actions, emergency active. So that's all my healthy states. So I've got a true and a true, and I've got a true. So because we've got 3 trues there, let's just use an AND gate. AND gate. Safety okay. Now it's only bringing up 2 points, but all you do is right click, pin slots, and I'm going to put another tick in C. Now sometimes I name my blocks inside, but really, do you need to name that when you can just see all them 3 into that AND block? Not really, but let's just, because we can. Fire, safety, gas valve. There you go. All true. So all that's good. So that can go straight out into that one, and it can go straight out into that one. So what we'd do is we'd cut it out of that, because I've actually done 2 different things. Let's just move that down and that one up there, and we'll stick another AND gate in there. In fact, we'll duplicate that one. Let's just rename that gas. And we'll probably never ever use this, but this one we're just going to be putting in our fire and our safety, and we're not going to be putting in our gas. So we can take out views, AX slot sheet, just delete that. It will automatically just put an INC in there. And pin slots, let's take out that and put that into there. So safety and fire, that one's just safety and fire. So rename that safety, fire. So we could use that safety for anything that doesn't use gas. And we use that safety for anything that uses gas. And safety and fire. So I'm just going to rename that now. That's all, that one there. Views, AX slot sheet. Safety and fire. Healthy. Safety and fire healthy. True. Gas safety. So if I take off that now, the gas, put that back to normal. We've got that false, the gas safety one, and yet the other one is still true because we have got the fire alarm and the emergency stops still okay for any plant there. So that's how our safety's done. That was easy enough. So the next thing, I'm just looking at the spreadsheet, but I don't really need that anymore, so I'm going to close that down. I can just view everything via this. So we've got AHU1 and AHU2, and we've got time clock. So let's start with AHU1 first of all. So new folder, or should we do AHU2 because it's got 2 extract fans, and then we can duplicate it to AHU1 where it's only got 1 extract fan. So yeah, we'll work that way. So we're not duplicating, we're taking away from the logic rather than adding to the logic. So folder AHU2. Ah, okay, that's gone to AHU3 because I've got AHU2 there. So rename underscore 2. That's better. So what do we want in here? Well, we need the time clock. So scheduler, we need that. We need to know that we want to be running, don't we? Without a doubt. Set to false. So we need to know whether we're running. Then we need to check that our safety is okay. That's for an AHU. So I'm going to link just the fire alarm. Oh no, I'll link all of it, the gas and the fire below to it. So that's my safety. What else do we need to know on an AHU that we've got here in our app? So we've got the supply temperature, extract temperature. So we've got some numeric writables. Supply temp. Pin slots. Take out my in16. And we want to put this into degrees C, which is there. We don't want to put histories on because we've already done the histories. There's no need to put histories on there. Set to 0. Supply temperature. And no need to put alarms on there because we've done it all as well. Extract temperature. So we've got our supply and our extract on AHU2. We've got an AHU2 bypass damper, which is an output. So let's just duplicate that, and that's going to be a bypass damper. And it's certainly not going to be in that, it's going to be in percent. Again, we haven't got no histories to put on there, anything like that, we've already got that. So that's our output. Just move that out there. What else have we got? What else have we got? What else have we got? AHU2 DX unit fault. So it's going to be one of them. DX fault. So the question is, do we run the AHU if we've got a DX fault? Maybe not. Supply fan flow. Supply flow. We can change that text for ourselves. So no flow, flow. The DX fault one, we can change that to fault, just so that we know healthy. And we can change our safety because we know that that's going to be healthy. True is healthy, and that is fault. Not that we're displaying any texts or any alarms via this. And we can change that to occupied and unoccupied. Again, you can just leave it if you wanted to. As default. Why? If you wanted to. True and false. Default if you want. Well, I've just changed it. Right, what else have we got? So I've just don't know why I've still got that on there on the other screen. Supply fan flow, we've done that. Extract fan flow for 1 and 2s. Okay. Duplicate. Extract fan 1 flow. Duplicate. Extract fan 2 flow. And while I'm at it, let's just duplicate one of them and extract fan 1 enable. Put that over there. Change the values to enable, disable. And duplicate for 2. And duplicate for supply. We don't have to number it because there's only one supply fan. Put that underneath there for now, out of the way. So we've got our flows there. Frost status. We've got a frost status. Duplicate frost. Now that is frost on a true. That's going to go in there because these are going to be my don't run type of blocks there. And booster set fault. Well, I don't give a damn about the booster set for the AHU. Because this has got DX. So I don't think I'm interested in booster set fault for any of the AHUs. Not interested in all that lot. Yes, we've done our supply enable. Oh, gas heater enable. AHU2. So I do. Ooh. Okay, so I want to basically have a enable for the gas heater. So my safety's definitely got to incorporate the gas. Which is everything. Oh no, sorry, it wants to be all of it. Yeah, okay, I'll leave that as it is. So gas heater enabled. So duplicate gas heater. So we've got a AHU with a gas heater. For when we want heat. Okay. We got DX unit stage 1 and 2. So that DX unit now I know is cooling. Without a doubt. Because we've got a gas heater enable. So I know that's my cooling. DX 1 and 2 now. So let's go to duplicate that. Cooling. DX stage 1. And duplicate cooling DX stage 2. Not interested in squash courts for the AHU. I think that is all my blocks. Now we're going to have a set point for the AHU. So that is going to, let's just do that at the moment now. Duplicate AHU. Now we'll be working on supply because the DX unit and the cooling will be in supply, so we won't be working on return. So AHU supply SP for set point. Right, pin slots. Let's take out that in 10 and let's set that to a set. And let's put in a set point for us of say 23 degrees. And as you probably noticed when I did that actions, we got these here. Well, I don't want them playing around and emergency overriding these particular ones, because this set point will be shown on the graphic. So views, AX slot sheet, emergency, and pressing the shift key and that, and then config flags, and I'm going to hide them so they can't change that on the graphic. So actions, you've only got the set there. Good. And if you can hear rain, it's because it's raining. I apologise for that. I need to soundproof this a little bit more. That I think is it. We'll probably put some mismatch alarms in there. So let's put these points to the outside. So there's my points. Not in that order there, but the points as I added them in. If I wanted to move them into that order, I can right click that and I can do reorder. Scroll that down, and after schedule and safety I add DX fault and frost, so I can move that up and I can move the frost up, and then I've got supply flow, extract fan 1 and 2 flow, so I can take them and move them up. Supply temperature, extract temperature, and I've got, which won't be going to the outside. And then they've got the bypass damper 1 and 2, supply fan, gas heater, and cooling. So I've now moved them into that order. But anyway, composite. Scheduler, well, that's going to be coming in on in 10. Safety is going to be coming in on in 10. DX fault is coming in on in 10. Frost, you guessed it, in 10. Supply, of course, their inputs into the folder. Again, that's an input. That's an input. That's an input. That's an input. Not using that one. Bypass damper, that's an output. That's an output. That's an output. That's an output. Output. And another output, and the final output there. Now, because I've got it all in order here, I don't have to remember what I've done there for doing the text. I can just go OK, it's put the nibs in there for me, and it's like, oh well, what did I start with? Well, what I do now is views, because this screen will go, and AX slot sheet. So I've got all these that I've got a name now, but because I put them in order down there, I know. I mean, yeah, this gives you a little bit of an example as well of what they are. So you really don't have to worry too much about that. But that is scheduler. Don't worry about that because the display name is already assigned to a different slot. Don't worry about it. It's because I've used the word scheduler in there as well. It still allows you to safety. we're going to get the same error here. DX fault, well, we're not going to get the same error because I'm just going to put DX space fault. So it's going to allow that. Frost, it will give me the same error. Supply flow. Extract 1 flow. Extract 2 flow. Supply temp. Extract temp. Extract temp. Okay, bypass damper. The next one is extract fan 1 enable. Control key C. Control key V. Supply fan enable. Gas heater enabled. Cooling stage 1. Cooling stage 2. That's it. Link mark. Well, we don't need to link mark AHU2 there because it's right at the side of me. And the safety, we're going to use all the safety, including the gas we want for that one. So I want to link that one, which is false at the moment, because my gas is not on. Let me put my gas valve on. DX fault. Well, we've already link marked that, but the DX fault is there. AHU2 DX fault, link to, out, into there. AHU2 frost, link to, out, into there. Supply fan flow, link to, out, into there. Extract fan 1 flow, link to, out, into there. Extract fan 2 flow, link to, out, into there. Supply temperature, link to, out, into there. Extract temperature, link to, out, into there. Now the outputs. Bypass damper for AHU2, link from bypass damper into there. Now I want my outputs for this. AHU2 supply fan enable, link from supply fan enable into there. Gas, link from gas into there. Extract fan 1, link from extract fan 1 into there, link from extract fan 2 into there. Got the cooling stages now, link from cooling stage 1 into there, link from cooling stage 2 into there. All my links either side. All I've got to do now is write the software inside there. So I'm going to put you on pause while I have my dinner, and then we will start on the software. Right, speak to you in a bit. Right, I don't know about these extract fans, but I think I'm running both extract fans at the same time. But I don't know yet. I'm waiting for confirmation from the engineer whether we run one fan or we run two fans. But at the moment I'm going to write the logic that we enable both fans at the same time and prove flow. Because we've got a gas heater here, does that mean that do we not run the AHU when the gas valve is closed? Because we can still do cooling. So I would say that we would still run the AHU if the gas valve is closed, because we've still got the DX cooling and it may want cooling. So we're going to leave it where I'm going to change the safety here. So where I've got the safety going into the gas safety, I'm going to put that into the safety and fire alarm instead. Naturally, fire alarm or emergency stop, we don't want to run the AHU. But then I am going to install the gas one. So let's just duplicate that, and that is gas valve open, and that's going to be open, and that's going to be closed. So this will show you what I do here. So I'm going to composite that again, AHU2 there, right click, composite, find the point I've just done, which is always going to be at the bottom, in 10, but then I'm going to just move it up to my ins, and I'll put it underneath frost. And then I'm going to have to do the text, views, AX slot sheet, and there it is there, gas valve position, open or closed. And then if I link mark my AHU2 and I go to my gas valve status, link to out gas valve position, which is currently open because I've overridden it to open. So now we'll start on the logic. So I am interested in just the scheduler, i.e. we want it to run, and the safety. I'm not really interested in DX fault, because if it's in fault we could and the gas is open, we could still run the AHU, so we don't really want that. So we just put in here safety. Naturally it's not going to like that because I've already got the safety here, so I'm just going to just put OK and put in the occupied and put in the healthy. So as soon as everything's okay, fire alarm's okay, that's time clock's asking for it, we will start immediately, because we won't be doing the bypass damper yet, that's going to be doing that on the return temperature. We will start immediately the extract fans, 1 and 2. Because I don't know whether they're due to standby or what, but at the moment I'm clean. I'm putting it as they are always, both of them are running at the same time. Right, so now we've got some flows coming back, or we will have once it's live, and eventually that will say flow. So I'm going to put an OR gate there, so at least we've got one flow coming back to me from both them before I put the supply fan on. So extract flow, but it's an OR gate, so it's either one or the other for the moment. So once I've proved that I've got extract flow from one of the fans, I can go ahead and put the supply fan on. Right, let's move some of these around now. Let's put that up there and put that up there. Nice and simple logic at the moment. Right, the next thing we want to do is we want to know what the supply temperature is. So let's put in a loop point, and we'll put that in for, I'll just put AHU in there for the moment. AHU should we do AHU heating and cooling and just have one loop point for that? Yeah, we will. We're going to have one loop point only that's going to do heating and cooling. I bet you're going to think to yourself, well, how can you do that? But we'll show you. Pin slots, loop enable, that can be from our safety. That can be from, no, even the supply fan, because we don't want to be doing this without the supply fan running. So really we want our supply fan flow, so we will use that in a minute. Let me just put some of these points in there. Proportional, integral, minimum and maximum. Well, I don't know whether we need to adjust them, but I'll put them in there anyway. So supply temperature is going to go into our control variable. Our set point is going to go into there. Our control for actually running that loop is proving that we've got a supply fan flow. Seeing that in the supply we're going to have our heating and our cooling. So that's the only time that's going to run when we've actually got a supply fan flow. Oops. Otherwise we don't want to be doing that. Right, so currently we're at minus, so I would expect it wanting to do some heating. So let's reverse our loop action, and we've got to prove that we've got flow, so let's just enable our flow. Control variable, set point. Let's put in our proportional of a 2, our integral as a 1. Save, and that should ramp straight up, and it has done. 100%. In fact, we'll put that as a percentage. We'll just put percentage here. I'm not bothered about the decimal place at the end, we can keep that. It's not shown on the graphics anyway. So we want heat. So in order to have heat, we've got to make sure that we have got the gas valve open. So we definitely need that to be on. So let's use a numeric switch. Numeric switch. Gas OK. Heating go. So that's our switch. So that's our true that we are open. So we could actually go into the heating side of it. Let me put you on pause because I've got a phone. Right, where was we? Gas heating. So we're gas heating there. So at 100%. So what I'm just going to do first, because this is actually going to be maximum output 100, minimum output minus 100. And I want to put in there, well, I want both my blocks across eventually, but I want my minimum and maximum blocks. Let's just take both of them across. So this one is going to be my heating. And the minimum I'm going to set to 0. So when it goes into the minuses, it will only still display 0. My maximum I'm going to put in there, but I'm going to put 0 in this one as my maximum. So I'm only going to be displaying minus figures in there. So I'm just wondering why I've got 100 there. Because I don't want that there. I want another one of them. Duplicate. Cooling. And I want to put that into there. And that's why I've now got that there. When we go the other way, so let's just put actions, emergency override. Let's put that to somewhat stupid like 200 degrees. Delete that one. Rename. Heating. Okay, so there's my minus 100, which minus 100 is no good to me. So ABS value, cooling DX, put that into there, and there's my 100 for my cooling. And then we put this back to normal temperature, and then there's my 100% there and 0 DX. So basically we're using one loop point, but then we're going to take these from here to the various points. So as for heating, when my gas valve is open and it's asking for heating, we can actually just operate a gas heater. There's no 0 to 10 or anything like that. So that's fine. But I'm going to change that 100% to now a true and a false. Presume it was at 0, then it would say disable, and when it gets to a 1, it will then enable the heater. But I don't want the heater to be enabled at just a 1%. I'd rather have it enabled a little bit higher than that. So I want to use my greater than or equal to block and start heating, and we put that 100 in there, and at the moment we'll set it to start heating. And I don't want the user to adjust this, so we'll set it to start heating at 20%. So once I get starting to get to 20%, I'm going to hit a true, and I'm going to enable my heating, or enable the gas heater for AHU2. And I presume it does say AHU2 for the gas heating output. AHU2, it certainly does. So that's us enabling the heating, but we've got no control on the heating. Not a problem. Now what I'll do is, while I'm in here, I will just move that down, move that up to there, move that up to there, and move that, too far, up to there, and let's just put a gap in between that and that. Them two can go together, them two can go together. Right, so that's it when it's heating. So let's change it now so we're cooling. Put a stupid temperature in there, 200 degrees. We're straight to minus 100 now, and we've got 100 there, and we've got 2-stage DXs. Now we can use the same as what we've done there twice and put in the stages. So first stage 20, say, the second stage 80. And I probably really want to put a user adjustable point there for when they want that to work. So duplicate that, start cooling. STG1. Make that the same length as that. And duplicate, start cooling stage 2. And we'll put stage 2 at something like 80%. But we're going to make this client adjustable. And then that will go into that, and that will go into that. That's that bit done, but apart from our adjustables. So let's just do our adjustables now. Duplicate AHU DX STAGE1 set point. And it's going to be in percent. We'll take out the decimal place on this one, and we'll make it so that they can go from 0 to, well, I'm going to have to give them the 100 just in case. So 0 to 100 they can set in there. And actions, set that at the moment to 20, and duplicate stage 2. We'll set that to 80. So 20 into there, 80 into there. So they can select that. I'm not going to do it with the heating one. I'm going to leave that it can only be adjusted via the engineer. So that's that done. But what we've got to still do is work on DX fault. Right, so we need to tie into this output the DX. So let's cut that. Let's cut that. And let's put an AND gate in there. DX. Okay. So that's going to give me a false. So we're going to put a NOT gate in there to reverse that signal. NOT gate. DX. Reverse. So now I've got my true. Put that into there. Rename. DX OK. Stage 1. So now we put that into there, and then we put that into there. So we've incorporated the fault. Duplicate. Put that into there, put that into there, and put that into there. So if it does go into fault, we won't try and run the DX. Right, and we've got stages. And we've got our PI loop, which is plus or minus. Because we're plus 100 and minus 100, I'm going to change that prop to a 2, and the timing, the integral, to a 4, sorry, and a 2. So I've doubled. Normally I use a 2 and a 1 from 0 to 100, but I want to just double that at the moment, purely because of going, basically instead of doing 100, I'm doing 200. So that's good. So now the extract temp of frost, we haven't done the frost. So frost, we certainly don't want to be using DX. Definitely don't want to be using DX if it's frosty. So let's just do a duplicate and just do a frost reverse. So we're healthy, so I can put that into that one and put that into that one. Move that down, down, and down. And views AX slot sheet. DX fault. Frost. Enable. Views AX lock sheet. Enable. Frost. DX fault. Frost. So we're all okay. In fact, I should really just put that as no frost. No frost. And really, DX fault should be DX healthy, if we're being correct. No frost. DX healthy. Views AX lock sheet. DX healthy. Enable DX healthy, no frost, go. Enabled on those set points. Right, return air. So if the return air is going to be above the set point. So let's say return air is actions, emergency override. Return air, I'm bringing 25 degrees back from that. Let's do another loop point, because this damper's 0 to 10, so I need to do a loop point from 0 to 100. Bypass. Control. Bypass damper control. Pin slots. Loop enable. Set point control variable. Prop int. We're only doing 0 to 100, so that's going to go out to there. That's going to be in percentage. And our control variables that. Our set point is that, but I'm just wondering whether to add 1 degree extra onto that as a precaution. I think it might be wise. I can always put it back to not doing that. Set point, add 1. And then we put a 1 in there. So that set point now is 24. And then we put that value into our set point there. And we need to change this to reverse action. We need to put a 2 in there and just a 1 in there. 2 in the prop, 1 in the integral. And why aren't we? Okay, set point's 24, control variable is 25. My loop's enabled, 2 and 1. Why aren't you working? That's because of you there. You should be counting up, which you are. And you're slowly now opening up the bypass damper to let the return air mixed with the new fresh air to help on the heating. So that loop wants to be enabled the same as, well, that loop's going to be enabled, which is supply flow, because supply flow won't work if extract's not working anyway. So we can use the same loop to enable it there. And because we're 1 degree above the set point and we are heating, now how does that know that we are heating? Because I've got, see, I'm not heating, am I? I'm cooling. So I only need that to work when the heater's enabled. No, I don't, because I don't want to use the heater if I can help it. But I certainly don't want this working when I'm actually cooling. So I've got to link the cooling up. So both these have got to be off before I will, because I presume the bypass damper is only for heating only. So I have got to make sure that those two aren't running, or if they are running, I don't open the bypass damper. Otherwise I'm going to, mind you, I'm controlling to the set point and I'm controlling to the control variable, the extract temperature. So if the extract temperature, if those cooling's running, that extract temperature should be lower than what the set point is anyway, by rights. So it should never ever happen where the bypass damper will be opening if it's cooling. But just to be on the safe side, any one of them stages. So, or DX running. Take that, take that. So DX is running. True. And then we will just use a simple numeric switch. Put that into there. So, and then this one is going to go into the false. And then the output of that is going to go into there. And that's DX off. Just leave it at DX off. So that will stop us returning the air when the DX is cooling. Just as simple as that. So we've joined all the points together, but there's still a few things I want to do there. I want to do some mismatch alarms. We'll start with the supply fan. So I'm going to use what we call an XOR. Here we are, XOR. And I'm going to call that mismatch. And I'm going to put my enable, supply fan enable in there. Let's just put sub mismatch for supply fan. And I'm going to put my supply fan flow into there. So we've got a mismatch because I'm showing I've got flow, but I've not enabled it. So that's like the flow switch is stuck on. And vice versa, if I don't have a flow, emergency auto, and I enable it, I get a mismatch again, i.e. supply fan's enabled but I don't have flow. But we want some sort of timer to just time out first. So we need to go into our timers here and we want to put a Boolean delay in there. Wait. It won't take any more than 2 minutes to basically get the flow switch to work. That's gone true immediately because I haven't put in the 2 minutes, hence it was just 1 second. So that's why that's gone true straight away. In fact, I'll show you. I'll turn it back off. So now we're all false. We're not using the out not, so I can just take that out. I turn that on. We got the true, but we haven't got the output there. But when we do get the output, I'm going to put a Boolean writable in there. Supply fan mismatch alarm. Put that output into there. And I will change the true to alarm, healthy, and then I need to go into my AHU2 here and put an alarm in there. An alarm, Boolean change of state alarm. Mismatch error check fan flow switch. I'm making it generic so it's for the extract as well. Or enable healthy, no mismatch, and fault. save that. And we've got an alarm there on the supply fan because of that scenario. Right, so that's done for the supply fan. We want to do the same for the extract fan. And do we do it for extract fan 1 and 2? Yes, we do, because we've got an extract fan 1 and 2 flow there. So duplicate ext1 mismatch. So extract fan 1 into there, extract fan 1 flow only into there. Duplicate extract 2 mismatch. Extract fan 2 flow into there, extract fan 2 into there, and then rename that sup for supply. Duplicate extract 1, wait 2 minutes. Duplicate extract 2, wait 2 mins. That into there, that into there. Bring that back across there. Take out in 16. Duplicate extract fan 1 mismatch alarm. Into there. Duplicate. Oops. Not that in there. After the timer. Duplicate extract fan 2 mismatch alarm. Put that into there. So that's going to go true eventually because we've got extract fans are enabled. That's the reason why. And we don't have any flow switches coming back because I never overrid them. So they're going to show an alarm. In fact, I might move them 3 or leave them there but move them to the outside of the folder. So we've actually got them showing on the folder. So at the moment, if I go into here, you will see they're not in the folder. But if I do a composite and do that one, so the output of that, the output of that one, and the output of that one, they can then see. So that was supply and these are extract. So views, AX slot sheet, sup, or put supply, extract 1 and extract 2. And they're both in alarm at the moment because we're asking for them to run. Let's put the flow switch on. That goes out of alarm and that goes out of alarm as we expected. Right, that is it. We have done the logic for that. I'm putting everything back to normal. Actions, emergency auto, and I'll put these back to normal again. Actions, emergency auto, actions, emergency auto, Actions, emergency auto. Okay, so we'll never switch on the gas heater because of the gas valve. We won't do the bypass damper if stage 1 or stage 2 cooling is enabled. Bypass damper is working on heat only. Bypass damper control is only for heat. And why have I got that enabled? Emergency auto. So that is done for AHU 2. So if I duplicate that for AHU 1, what have we got to remove? Well, we're certainly going to still have the scheduler, and we're certainly going to use, not that one, the safety. Now, I don't think DX1, I don't think we've got on AHU1, we've got the frost status, link mark, link to, out, frost. We don't have a DX1 fault, so we don't have anything there. We've got whole supply and extract fan flows, so link to, out, supply flow, link to, out, extract flow, which is only one extract. AHU1's only got one extract. Not interested in any of that. AHU1 whole enable, so link from, and supply fan enable is there to there. Extract fan enable, link from, extract fan enable, gas heater enable. So we do have a gas heater. But that's where it ends. We've only got one extract fan and we don't have DX, so we have no cooling. So what I think we should do is take out what we don't have. So we don't have that. We don't have that. We don't have any of them. We don't have any of them. We're only doing heating. We're not doing cooling. So let's put that to 0. And we don't need to mess around with that. That can go straight into the gas heater's okay. We've got the gas valve open. That's there to start heating at 20. Supply fan, we don't need extract fan 2. We can get rid of that. And we've still got a bypass damper. Frost, not interested in frost. In fact, what we can do, and we should have probably done it on AHU2, that if we have got the frost, no, we don't want to enable the gas heater if we've got a frost, because we may not be at set point. So we need flow, we need it running, supply fan running in order to, so really we're a bit stuck there. We either don't run it at all and tie the frost into the safety there, because we can't put that on, so let's tie the frost into the safety here. because frost. We want a true into there. Pin slots, put C in there in case anyone cuts it out and wondered where it went to. Pin the C in. So frost is healthy. If frost isn't healthy, then we don't really want to run the extract fan, do we? Rename. I can take out the one there, and I can take out the one there. Take out the one there. Take out the one there, because we've only got one supply and one extract. And we're tying the frost into the enable. Yeah. I'm just wondering if there's a frost. I don't know whether the frost alarm will be a latched alarm, and until someone resets it, it won't do anything. I.e., or it's going to just be used for indication. We still want the AHU to run, in this case, and put some heat through the heating coil to stop that frost alarm. So I'm not too sure whether it needs to be tied into the safety or not, and just use it as an alarm sending to them that, hey, you've got a frost. I still think they would want the AHU to still run. So I'm going to leave that as it is, but I'm going to just take out that link so that AHU still runs, but we can put it in if we need to. Yeah, and that's where it's like AHU2 will still run even on with a frost. Okay, so that's AHU1 and 2 now done. Views AX slot sheet. Just take out the one there. Right, that's the 2 AHUs done. The rest is going to be pretty simple, but let's we presume we do the domestic hot water first. But I'm going to have a break and make myself a cup of tea, so I'm going to put you on pause. Right, I'm back again. Just in case you think, well, how's that happened? I put these in. I forgot them when I paused the video, and also the bypass damper, well, I've put them in now for AHU1 and 2. So if you hover over there, I mean, you look in the bottom left hand of the screen, it says AHU1 extract out and AHU1 supply out there. And then this one, AO1 bypass damper, AHU1 in 10. So it's 10 here at the bottom. It was down here, we was looking at it. Down here. So look, if I go over that, and you can see the AO1 bypass damper, AHU1 in 10. And if you look at supply, logic AHU1 in, and that one there, extract, universal input 3, AHU1 extract, universal input 2, AHU1 supply. Right, let's start now on the domestic hot water. Let's just make a folder, domestic hot water, and let's put our points inside it. new folder, and what have we got? We've got those outputs there. Let's concentrate on the inputs first. So heater 1, 2, 3, I presume these are gas heaters, so we've definitely got to have the safety, and we've got the scheduler as well. So instead of just reinventing the wheel, let's just go back into AHU1, take that, copy it, put it into my DHW1, in fact paste it in there, and that's doing that because of a DHW there. So rename hot water. Right, so we've got that, Let's look at my inputs. What else have we got? Gas valve. I do need to know that the gas valve is working. Did I have that on the AHU2? Gas valve, yeah, so I'm just going to copy that and paste that into there, so I know that my gas valve is open. And their outputs, flow, we've just got one flow there, and that, apart from output, oh, and then we got some faults there. So let me just take them, copy them, paste them into here, and these naturally got the histories and the alarms attached to it. So 1, 2, let's have it in order, 3, 4. So I'm going to have to take them out because we don't want it twice. We don't want them twice. Delete them. Delete them. Delete them. And delete them. I'm also going to rename them as well. Oops. I don't want to replace. I want to delete. Rename. Take out that. Rename. Take out that. Rename. Take out that. And rename. Take out that. This video is naturally going to be a long video because I normally don't show everything right from start to finish. I normally put you on pause, do a few things, and then show you how I've done the logic. But this is going to be a long video. So we've got the faults, and those are our only inputs that I can see. Oh no, we've got another one. Copy that, paste that there, just take out that, okay, and then I need to actually take out, oh, and the domestic hot water as well, the booster, we need that in here. That's going to be up at the top, or near the top. Where was the booster that I've just seen? That one. Copy, paste, we need that in there. I'm just wondering whether we need the booster in the AHU safety, but the DX side for AHU2 doesn't need the booster. AHU1, because it's doing the gas, no, it doesn't really need the booster. In fact, I don't think this one really needs the booster, because it'd be treating water that's already in there, but let's leave it in here for now. But I don't think it's critical. If it goes into fault, Yes, I know, but they're going to know by an alarm. But do they really need to stop the hot water gas boilers working because the booster's gone into fault? No, I normally don't put a booster in my my logic for that. Right, let's go for the outputs. New Boolean writable HWS return pump. Yeah, well, that's going to be on 24/7 into or on all the time. So the only control of that is the time scheduler. Even if there's a fire, it doesn't make any difference to me with the pump water running, really. Emergency stop. Yeah, someone could have got electrocuted, I suppose. We would probably need that. So we'll tie that into our safety. In fact, we'll just carry on and do that now. Let's just go to my kit control. And let's put an AND gate in there. Safety, okay. Put that into there, put that into there. Take that, put that straight into there. Safety okay. Time schedule's on. Yeah, that's fine by me. What other? So heater 1, heater 2, heater 3 and heater 4. So we need a set point, definitely, and we're going to be controlling. We need the gas valve open, without a doubt. So I'm going to put that in my safety. We've got to have the gas valve open. Mind you, do we need it? We could still run the secondary pump without the gas valve and it can still circulate water around. So I think I'm going to take it out of that and still run the secondary pump on its own, flowing water around, and then I'll have another AND gate taking in the gas. Pin slots, put in that for the gas. My gas valve in there. I'll still put my fault in there. I'll still put that in there. Yep. Return pump flow. Well, I know, looking at the drawings, that's only a contact on the contactor on that, so it's not a proper flow switch. So it's always going to be made because it's on the contactor that energizes the pump. Let me show you what I mean. If I can just get to the drawings, I'll show you what I mean there. And existing panel drawings. And if I open up that, right, where are we? Open with photos. Right, let's find it on the I/O first. So let's just go to the I/O of the Siemens. And I'm trying to find, not there. That was my hot water outputs there. The temperature sensor, the booster fault. But somewhere I have got in here or should have in here, the one for the HWS return pump. Extract, supply, gas, return pump. Yeah, a current, oh, okay, it's using a current relay. It's using a current relay to sense that it's running, so it's not on the contactor like I said it was. It's using a current, so naturally if that does decide to stop running, it won't be drawing any current, so yes, we do need to use it. Alright, I'll confirm we do need that in here. So that can be a mismatch for our system when we're ready to do it. I think we better composite all these out first, but I think I need to add in my other outputs first, which is just the heater enables. And I'm going to change that again. I'm going to delete that HWS return pump, because I'm going to go into my AHUs logic. Oh no, I don't need to. It's alright. I was going to put the composite on the, not composite, the totalizer on there, but I don't need to do that. So I don't think I can do a control C that I can't, so let's do it again now. HWS return pump. Pin slots, take out in 16. Enable, disable. Save. Actions set to disable. Duplicate, and I want heating, isn't it? It's HWS heating enable heating 1. Just check that's right. Hot water heater 1. Enable hot water heater 1. Duplicate 2. Duplicate 3 and 4. That's it, isn't it? That is it. So let's composite this now and see what the mess I've made of here. So scheduler, safety, gas valve, HW, my faults there, so let's just reorder that because I'll be using that for doing my labelling. Fault. No, I can leave that as it is. I'm going to leave it as it is. Reorder, composite. So scheduler, input, safety, input, gas valve open, input, hot water heater 1 fault, hot water heater 2 fault, hot water heater 3 fault, hot water heater 4 fault, pump flow. Booster fault that I don't think we'll be using. And then my outputs. HWS return pump, enable. Hot water heater 1. Hot water heater 2. Hot water heater 3. Hot water heater 4. Yep, they're all on. Yep, they're all on. Views, AX slot sheet, scheduler. We're going to get that error. Safety. We're going to get that error. Gas valve open. No error. HWS heater fault. Number 1. Control key C. Number 2. Control key C. Control. Number 3. Control key V, I mean. Number 4. Flow. HWS. Return pump. Flow. Booster. Set fault. Cold water. CW. Secondary pump. Secondary return pump. Water heater 1. Enable. Water heater 2. Enable. Water heater 3. Enable. Water heater 4. Enable. Right, we need a set point. So let's go into AHU1. Let's just steal the set point that we have got in there. That would do for me. Copy into there, paste it there, and HW hot water supply set point. And that is going to be in the range of round about 62 degrees. We'll let them set it no lower than 50, and we'll let them go no higher than 70. Right, let's start working on some logic. Oh, I haven't got the flow temperature, have I? That's no good to me. Not without a flow temperature. HWS flow. Pin slots. A degree C. Temperature. Degree C. Save, save. We'll composite that to the outside. Composite. Expand. It's going to be at the bottom. In. Move it up to my inputs up near the top. OK. Views, AX slot sheet, and HWS flow temperature. Right, let's see what we've got here now. I'm going to just link mark that. Domestic hot water scheduler, our safety. I'm going to use that safety, which includes the gas and everything, even though I've got it there as well. Why not? Gas valve, don't want that, I want my inputs. Gas valve, where are you? Gas valve, link to. That's a bit pointless, this one now, this gas valve open one, because at the end of the day, if the safety's not on, that's not gonna, anything's not gonna work anyway, but hey ho. Another precaution, I presume. HWS flow in there, return pump there, my enables, so I want to link from secondary pump into there, link from water heater 1 enabled into there, link from water heater 2 enable into there, link from water 3 enable. I think he's only going to be using water enable 1 and 3 because that's how it's wired up in the sheet which I showed you right at the beginning. So I don't think he's going to be using the individual ones. I think he's just going to be using water heater 1 and water heater 3. In fact, use AX slot sheet. Put a star there, because they're the ones he's going to be using, unless he decides to start wiring the panel differently. Faults, I want my faults. Here we go. Link to, out, 1 fault, link to, out, 2, link to, out, 3, link to, out, 4, and then I need my flow. Link to, out, flow, and my booster set, cold water booster set, link to, out. So really I'm going to use my cold water booster set, aren't I? In with my safety. Do I want to put it in the, that's a normal, that's my gas. So no, I want to leave that as it is to just run the pump and put that also into there for my safety for that. Right, now I can do my logic for these. They are binary outputs. So that's my flow, that's my set point. What are we going to use? We are going to use the good old loop point, with a difference. Well, not on the loop point, but coming from it. Set point control variable, prop int, that's all I need. So we are going to have our control variable into there, our set point into there. We'll set our proper to 2 and a 1, and we do a save. and we also want to do reverse because we are heating, not cooling, so we don't want it to be indirect. And we're okay to go if the gas valve is okay, the booster set's okay, which it currently isn't. So let's make him okay. Actions, emergency active. Actions, emergency active. Ah. Ah ha 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 ha. That's got to be a not gate there. Reverse the signal. Not booster. CW rev. D. Pin slots. Expand that to there. Move them across so it doesn't look untidy. Now that's enabled, that's at 100%. But we are going to now use a sequencer. Sequencer linear water heaters. We have 4 of them. Four water heaters. Delay. 2 minutes delay, I think. Do we make it user adjustable? Maybe we do. Pin slots. On delay active, off delay active, delay. Next stage off. Yeah, that's why not. Give them all that. Water heaters, so that one is into there. That one is into there. You can hear the Mac clicking its relays on. And that one into there, which is a good sign. It's not a bad sign, it's a good sign. It means our links are all working. Right, let's give them a delay. Duplicate that, and we go heater, sequence, delay. Oops. Set point. Bit of a mouthful. Heater, sequence, delay, set point. We'll do it in seconds. So we don't want temperature. We want time. And we do it in seconds because we all know seconds, like we know no minutes. And we are going to go -inf and +inf for the moment. I might put some settings in there that they can't go above. So actions set, and we'll set that at the moment at 120 seconds. Now, because this works in milliseconds, this delay that you see in 2 minutes at the moment is milliseconds as an input, we need to go into our multiply, and we need to take our seconds and times it by 1,000 to give us milliseconds. And that's going to be called sec underscore ms. Is that a capital M and a small s? I don't know, it won't make much difference. And put that into our delay. 2 minutes. So they can now adjust that delay. Take that, move that down there, and that's my return flow. put that up there. So they will delay themselves and put them on, and then that should come on eventually. But it didn't come on because I changed it to 4 after I did it. I think that is going to be the case. So let's cut that and let's put it back in again. Let's see what happens with that. I'm sure that's going to be all okay. Right. Now we want to, don't put them on if it's in fault. So we need AND gates in all them. And all them's going to have NOT gates, duplicate. So water heater 1. In. Duplicate. Water heater 2. Duplicate. 3 and 4. In. 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 And I want an AND block. Give me an AND block. And ENB water heater 1. And what we'll do here is we'll just do the renaming of the slots. So that's our sequencer, and that's it healthy. So our sequencer goes into there from out A, and that goes into there, and then that goes into there. Duplicate. That goes into there. Duplicate. That goes into there, and duplicate. That goes into there. That one goes into there. That one goes into there. And that one goes into there. Healthy. Healthy. And healthy. Now we could actually play a little bit here and expose our number of outputs, which is currently 4. But if they go into fault, we could get that to then go to 3, 2, 1 if we wanted to, rather than wait the 2 minutes for the next stage to come on, if we want to. So we can add up all them and we will get 4, of course. So let's put an add block in, and units healthy. Add in the C and the D, and 1, a true. Notice it gives me just a 1. They're my 4 units, and they're my number of outputs. And if we put a unit in fault, let's just do unit 2. It's not going to work, because if I put that in fault, it's still going to do 1 A, B, C, even though it's unit 2 that's in fault. So no, that's not going to work, because it's still just going to do it on the sequence. Unless I change this and don't use this sequence, or use it Yeah, because that's not going to work that way. So we could change it, and if it's one goes into fault like that one there, let's just take out these sequences. Let's delete them, and then let's put one in fault, which we know 2's in fault, but it's got 3 outputs. So now, because 2's in fault, that would be 1, that would have to be 3, and that would have to be 4. So you can use this as stage 1, stage 2, stage 3. And stage 4 if it was 4 stages. I think I'd rather wait 2 minutes. There is a way of doing it. I know of the way of doing it, but it's going to be a lot of extra logic for something that we're just waiting 2 minutes. It's not worth it. It really isn't worth it. Let's put that to 4. And put these stages back in again. Sequence, 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 sequence. Okay, there are all the water heaters on. Pump flow. Well, we only really want to return pump flow, isn't it? That. So, do we interlock that in with our loop? No, because you could still eat up. But that's monitoring the flow temperature. So yes, we do want to put that into our loop. So let's just bring that down, and let's take that up to there. Didn't go down far enough. And let's place that, because that will run, but we still need that safety in for the gas there. So I think I'm just going to stick another AND gate in. Rather than messing around with anything else, I'll just stick another AND gate in. So HWS go PMP flow. So there's my go, and there's my flow, and there's my enabling my loop. So I've proven flow, and I've got everything else A-OK, my booster set, my gas valve, safety and scheduler, and hey presto, I then start my water heaters if they're required. Yeah, that would work. Showing the minus sign of 62, they're naturally required because minus 3,270, that's very cold. So, well, naturally that's because it's not got a sensor connected to it. Let's put that back to normal, and that of course enabled that one then. I think I'm going to call it a day with this one, HWS. I don't think we can do any more now with that. So we've done AHU12, we've done our hot water, supply hall fan enable, that's AHU12, we've done that. Squash courts, reheat enable. Now what's my control variable for that? Because how do I know to put the reheat on? of the squash courts. Because I don't have a temperature of the squash courts. So how am I going to put the reheat on the squash courts? I can't, unless, and I don't know what AHU squash courts are. I know AHU 1 is a hall supply, but I don't have any more IO, so how do I know to put the squash court number 1 reheat enable and squash court number 2 reheat enable, and whereabouts is it in the building, and from what AHU is it being controlled from? That is the question that I need to ask Hall's frost data. So I presume it's going to be AHU 1, you know. Because we've got 2 holes, haven't we? So in fact, why have I got a time clock for Hall? Where's the bowl hall heating and sports hall heating? So I think AHU 1 is going to be the halls, and AHU 1 is also going to do the squash courts. So really I just need to add to AHU 1 see, that's an digital, yeah, that's an output. I just didn't put the DO, did I? Rename DO 10, rename DO 11, rename DO 12. Because they're just outputs. Them 4 there, them 2 there are outputs. And that's also an output, and that's also an output. Sports hall heating and bowl hall heating. And I can only do that from time clocks. So all I can do is enable the time clock, enable that. There's no logic involved in that at all, apart from if you want to just do your safety, which I presume you do. So let's do that, and I'm more interested in this squash court reheat enable and how I control that. So let's just do a new folder, and halls heating, and in fact, I'll tell you what we'll do. We'll just do a template for 1. So sport hall heating, and let's just go into there, take the scheduler, take the safety. I better take the gas valve as well while I'm at it. Not that I need it, because I'll use the safety for the gas. Copy. Paste that into there. And my output, new, don't want folder, new, Boolean writable, heating enable. Simple as that, really. Pin slots, keep my in 10, action set false. I'll do enable, disable. enable, disable, go OK, go save. Put my AND gate in there. This is simple. Start heating for now. I don't have anything else, so it must have its own thermostat built into it, because there's nothing else that I can do on that one. Composite it, pin slots. Don't want pin slots. Composite, sports hall, scheduler in 10, safety in 10, heating out, views AX slot sheet, scheduler, safety. I put gas safety because I'm going to use the gas safety there, and heating, enable, put our scheduler in for sports hall, our gas safety, link mark, and somewhere I have got an output for the sports hall heating. Link from heating into there. Duplicate that. BOWL. Link mark. Ball heating link from. Out into there. My safety with the gas, my scheduler. So now all I've got the question for now is, what do I do with squash courts number 1 and number 2? Reheat enable. So what I'll do is, it'll probably be in one of these AHUs, but I don't know the answer to that yet. So I'm going to duplicate that and squash courts. And rename reheat number 1. Duplicate reheat number 2, and I haven't even got no logic that I can actually put to basically stage that, so that definitely needs a look at. Composite reheating 2 will be that one. It is. Okay. Views AX slot sheet. Reheating 1 enable. Reheating 2 enable. Link mark. Where are you? Where are you? You're there. Link from. Oh, it'd be squash court number 1 and squash court number 2, won't it? So they both probably will be on. Views AX slot sheet. Reheating. Reheat. Squash court 1. reheat squash court 2. And then the scheduler. I don't have a scheduler. I don't have a scheduler for squash courts. Maybe I need one. Do I need one? Do I use Sports 01? I'm going to use Sports 01. And gas safety. Or do I give it another, I presume there's no harm in putting another scheduler in. Duplicate. Squash courts. I honestly think this would be from an AHU, you know, personally. And it may be AHU 2 with the cooling. Squash courts. But I reckon it's AHU 2. It's got to be AHU 2. That's the only one that's got the cooling. And I think you want cooling in a squash court sometimes, as well as heating. And if that's AHU 2, I need to ask the question, don't I? I'm going to put you on hold and I'm going to actually ring the client up who knows the site. Okay, I've got my answer back. It's AHU 2. So we get rid of that. We'll still leave the AHU 2 scheduler into there, but I need to add another input into there to say when the AHU is actually heating. So Boolean writable, AHU 2 is heating, and they just want to put them on when it's in heating mode. Pin slots, take out in 16. So that's just going to go into the point of there, into C in the end, so all three's got to be on, and we just enable all of them. I could have incorporated into AHU 2, but since I've gone to the time of doing this now, I might as well just add in this one just to show that AHU 2 is heating. And views AX slot sheet, AHU 2 in heating mode. And I think I will have gas heater enabled, because that's the only time it's actually going to work. So AHU 2 in heating mode. And that will put on the squash court heaters, both of them, when AHU 2 is heating. That's the logic done. Well, how long did that take? 3 hours 58. I bet you lot haven't been watching me for 3 hours 58. But if you have, well done. Sorry it's been a little bit boring for you. But now I am onto the graphics, so my logic's written. I just need to now do the graphics, which is something that can actually take longer, believe it or not, than writing the logic and doing the YouTube video at the same time. Naturally, doing the YouTube video at the same time has took longer. But thank you for watching, and can you subscribe? And if you did like it, by all means add the like button, click the like button. But thank you for watching. Bye.